9K, the quotient rule. So here we have another rule for you. This time the quotient rule is when we have two functions that are being divided by each other. So once again, if I've got a function y, which is equal to this time u divided by v, this is going to be the rule to be able to work it out. So v is my original function. Again, u du by dx is the derivative of u minus u multiplied by the derivative of v all divided by v squared. If you want to write it in a little bit of a simpler manner, dy by dx, remember using our informal notation, that will be v u dash minus u v dash on v squared. This time, it does matter what order you do it in. So as long as you remember that your first term here is v and u dash, so the derivative of u, then you should be fine. Let's apply this now to an example. So example 17, find f dash of x if f of x is equal to x or x minus 1 all squared. So again, let's separate these two functions. So this one is my u and this one is v. So let's write it up in a table. U is equal to x, v is equal to 2x minus 1 all squared. U dash is equal to 1 and v dash, this is the chain rule, I'm going to take the 2 out the front, multiplied by the derivative 2, which is equal to 2x minus 1. Now, remembering the rule that you must have the derivative of u in your first term. So this time, if you set up the table like this, you can get used to the fact that the arrows must always, this one is always your first arrow, going that way, and then this way is your second arrow. So you just need to remember that you would probably go right to left. It feels a little bit unnatural. So as long as you can remember it as your unnatural arrow, then you'll be able to remember which way the terms go. All right, so it's vu dash, so that's 2x minus 1 all squared multiplied by 1 minus, now it's uv dash, so 2x minus 1 times x, and that's all divided by v squared. So v squared is this, just my original function, 2x minus 1 squared, all squared. And now I'm just going to simplify this, so 2x minus 1 all squared minus 4x 2x minus 1 all on 2x minus 1 to the power of 4. Do not expand this denominator, just leave it as it is. One thing that we can do to the top, if you would like to simplify it, is I can factorize 2x minus 1 out of both terms. So if I do that, 2x minus 1, I can take only one of them out. That will leave behind one lot of this 2x minus 1, and then that will leave behind 4x, so minus 4x. Now the reason why I do want to do this is because these are now the same, these match, and because these are being multiplied, I can cancel out. So that's 1 gone, and then that will leave 3. So I do apologize for the messiness here, but my final answer will be 2x minus 1 minus 4x all on 2x minus 1 cubed. So please do try and simplify if you have the opportunity to. Next one, f of x, find the derivative if f of x is equal to x on square root of 2x squared minus 1. Again, this is u, this is v. Set up your table, u equals x, v equals, again, I'm just going to write it straight as to the power of a half. And now find the derivative. So that will be u dash is 1 and v dash will be, take the half out the front. This is the chain rule, so don't touch the bracket. A half minus 1 is negative 1/2, and then we need to multiply this by 4x. 4 divided by 2 is just 2, and then the x can stay there, and this will be to the power of negative 1/2. Now remember the order, you want to do it in the, this feels again unnatural, it's the right to the left, or I need to have u dash in my first term. That will be my first term, and this will be my second term. So now I can write it out. So I'll have 2x squared minus 1 to the power of a half times 1 minus x multiplied by 2x squared minus 1 to the power of negative a half. And that is all divided on v squared. So that's 2x squared minus 1 to the power of a half squared. So let's go ahead and try and simplify this. Now for this very first term here, that's quite nice. I can just leave that as a square root, 2x squared minus 1 minus, that'll be a 2, x times x is x squared, and then that's all on the square root of 2x squared minus 1. And this whole thing is on, luckily a half and 2 cancel out, that'll just be 2x squared minus 1. Now, how do we simplify this? So the first thing I want to do is get these two fractions here with the same denominator. So I can see that the fraction here, or the denominator here, is on 2x squared minus 1. So that's what I want to do to this side as well. So that'll be times 2x squared minus 1. And whatever I do to the bottom, I want to do to the top. So that's quite nice because that gets rid of the square root for the top there. So that'll just be 2x squared minus 1 minus 2x squared. And then this is all on root 2x squared minus 1. And to demonstrate how I can simplify this, I'm just going to use some simple numbers, and I'm just going to do it down the bottom over here. So for example, say I have a half, so that's like my top fraction, divided by 3. So what that would equal, if I were to write that out, that's a half divided by 3. Now remember, when you have any number that is being divided, all you have to do is change that to a multiplication and then flip that over. And what we see here is that the denominators become multiplied to each other. So in the same way, all I have to do here is multiply these two denominators. So that's what ends up happening because of this fraction divided by a single number. So you can see that this is the fraction divided by the number. So in total, this is what I get. The numerator stays as it is, and that is going to be divided by 2x squared minus 1, which is what's already there, and then again by 2x squared minus 1. I'm just going to get rid of the square root for a second and write it as 1/2. The reason for that is now you can see that the insides are the same, and now all I have to do is add my fractional power. 2x squared minus 2x squared cancel out. So at the top, all I've got is -1, and that'll be 2x squared minus 1 to the power of 1/2 plus 1 is 3/2. So yes, this quotient rule, it's not difficult, but it does require you to be quite proficient in fractions, particularly these ideas of dividing fractions by fractions.